The purpose of this experiment is to explain and demonstrate the principle of total internal reflection. For this purpose, we need a glass container filled with water, such as a vase or drinking glass. Important is that it's a cylindrical container wide and high enough to be clearly visible in the classroom. From the Photonics Explorer case, we take the laser module with a battery that should be new enough to ensure the light is bright enough. We also need a small bowl of milk or condensed milk, as well as an object to stir the milk into the water. To make the total internal reflection visible, we use milk to slightly cloud the water in the glass so that the scattered light can be observed from the side. Before the lesson, it's important to do some testing to determine the ideal amount of milk in the water. Once the milk is mixed in well, we can firstly demonstrate a total internal reflection at the air-water interface. The aim here is to demonstrate to the students that reflection not only occurs on metallic, polished or shiny surfaces, but whenever light passes from a more dense medium to a less dense one. To do this, we use the air-water interface. We shine the light sideways into the water, directing it diagonally upwards towards the water surface, and can clearly see the total internal reflection at the water surface. This confirms what we know from the law of reflection, namely that a variation in the angle of incidence will lead to exactly the same variation in the angle of reflection. This is clearly visible when observing the light's path from the side. In the second part, the aim is to show how the principle of total internal reflection is applied in our everyday life. By means of multiple internal reflections in a glass, this experiment is ideal for demonstrating how light is transported through waveguides. We shine the light from above diagonally through the water surface into the glass container. Depending on the angle of incidence, we create multiple reflections with a zigzag path that can easily be made out in the cloudiness of the water. Here too, it can be observed that adjusting the angle at which the light hits the water will influence the geometry of the light's path as per the law of reflection. If there is not enough milk in the water, there will either be no light scattering, or it will be so faint that the experiment will not work if the room is not completely dark. If the concentration of milk is too high, the light will scatter too much. In this case, the second total internal reflection will still be visible, but the light beam after the second total reflection will be very weak. We can experiment further by increasing the concentration even more. Here, it is no longer possible to see the zigzag-shaped path of light.